So what we're going to do now is head on to our Q&A session. I see that there has been a tremendous amount of talk in the chat window right now, but I'll rewind a little bit to our first set of questions. So all speakers, if you are still here, do feel free to turn your cameras on, unmute yourselves, or however we want to get this analyzed, and we'll start getting some questions answered that I haven't seen brought up in chat. And the first one will be to our first speaker, a question from Dean Epler. Bandwidth is like your monthly budget. No matter how much you have, it never seems to be enough. There will be a significant demand on bandwidth for things that will have nothing whatsoever to do with science. And I thought this was a good follow-up to that comment. Would we use this LiDAR 3D photogrammetry as part of the VR tools? Is the bandwidth able is the bandwidth able to handle that kind of throughput from LiDAR or 3D photogrammetric data?
Is that a question for me? Did you say first speaker?
Yes, yes. I'm sorry.
Yeah, I'm very concerned with bandwidth. I don't think there's enough thinking about it. And that's one of the reasons why I think letting the astronauts have these tools that they can use on the surface to be able to incorporate lots of data with some kind of a control from the Capcom potentially about how much kind of gets back and forth would be a good idea. I think we're going to run out of bandwidth, or we're going to have to find very efficient ways of using what bandwidth we've got available. So I think that these new tools that allow rapid analysis, combining of data, display of data in real time. If the astronauts are collecting things from various kinds of instruments or cameras, there could be ways of creating this scene around them that gets some idea of coverage, where there might be an interesting rock. So I think of this as something that doesn't have to necessarily involve a lot of bandwidth with the Earth, getting stuff back down to the Earth. And I think we are going to run out of bandwidth. Of course, there's never enough bandwidth. It's like there's never enough time, you know.
Right. Okay. Thank you so much. The next question here is to Cameron from Fred. How do you timestamp a map or a strategic piece of information that doesn't necessarily follow the surface mission timeline? Either it could have been created before the mission, done out of sync with the mission, or with ground ops, or just before or just after any specific timestamp timeline item.
Yeah, sure. Sorry, and if there's a little bit of crosstalk here, I apologize. In my co-working environment, we have multiple calls going on. But basically, I want to work with Fred on this question. That's a great question. I'm going back to my undergraduate physics education, where we learned about relativity and space-time, right? Space and time are basically, two sides of the same coin. And so they both seem like great ways to contextualize the rest of the mission data. But I don't have an answer for that. And I think that's a great question that we should investigate.
And as a immediate follow-up, this is from Mike Siebert. What kind of accuracy or precision is needed across the timestamps for all of these data collection systems for the time correlation evaluation of many 5, 10, however many data streams that there are?
Yeah, so what we've found so far is that, if you're synchronized to the second, that's ideal. We recently integrated still imagery with our CODA system for data processing. We've noticed that most camera imagery is accurate to within a minute because camera interfaces only allow you to set a time to within a minute. So that leads to some asynchronization. However, it's still useful, but if you're watching somebody talk, it sounds weird or looks weird if there's more than about 100 milliseconds of difference. But a good rule of thumb there, if it's within a second, that's perfect. If it's within a minute, that's still extremely usable. More than that, then you get into a question of, when did this actually happen? But we found the rules of thumbs aren't, that you have to be synchronized down to the millisecond, for instance.
Okay, great answer. Thank you so much, and thank you for the question as well. Another question going on to Saro. Can you elaborate a little bit on what processes you used in the pre-processing of your machine learning data? This is from John K, if you're still around in chat.
Oh, yeah, I'm here. Yeah, so mainly it was averaging and baseline removal. it's needed to prepare this spectra. But then we have also other processes, because if you have spectra from different tools, then of course you have to harmonize this data. But I suggest to have a look to the work that we have done, the paper on Analyst, where you can find all the details. I think it has been written in the chat. Otherwise, I will do now.
Yes, I already talking with John about this.
Okay. There's been a lot of talk in the chat very recently from your talk, Kirby. I'm not sure if you want to address any of these other ones. I know that there's been a lot just in the last few minutes as we've started the Q&A, but one of the biggest overarching questions that I think should be repeated for the general audience is, how different is this system than either having another astronaut on surface, or this is a great point brought up by Pam, why not have a specialized robotic assistant who is completely autonomous or mostly autonomous, that can do its thing in that environment, feed data into your mission control system, your mission control operation center, and then that's how you plan, pre-plan, post-plan data. How much do you gain from a ConOps perspective here?
So there's a few things here. One is, yes, the robot is used like as though it's another astronaut. And the word avatar, we're trying to capture that idea that we're taking a geologist's mind, a real person's mind, and allowing the robot to be an extension of their body, so that it can react much more quickly and with human level heuristics for interpreting geology in the field the way a human would. Whatever you would use another astronaut for on the surface, you could use avatar for on the surface, whether that's as a field technician or an independent geologist, or any variation in between. It could work directly with the astronauts, or it can go off and do geology when the crew's not available. And the avatar operator is working in what's called a model-mediated environment. That means the avatar operator is manipulating a virtual environment that responds in real time to their inputs. Their virtual environment is based on frequently updated real data from the moon, though, from avatars, imagers, and maybe LiDAR. And then they hit pause, and then those commands or those sequences that they did in the virtual environment then get converted to robotic commands to actually implement it on the moon. And so there's no perceptible lag while they're operating. But really, the ConOps are pretty limitless. I don't know if I addressed the question. There's kind of several things there, and I talked around it. Happy to elaborate, though.
Do you want me to follow up on that, or do you want me to just be quiet?
No, go right ahead. Go right ahead.
Okay, this is Pam. A robotic device is not as fast as a human. So unless you're tying it, you have a force magnifier attached to a human body. I have a hard time understanding how an avatar can be a substitute for a human being with our current level of technology. Unless we've really gotten breakthroughs somehow in heuristics, it doesn't seem like it. I can see where you can use something that's autonomically smart enough to go and take traverses someplace where pre-programmed, or you say go over there and get more data, and it doesn't matter how fast that operates because you're doing something else. But something that actually acts like a human in terms of their motion being as fast as an astronaut, I have a hard time visualizing that.
So. Couple things there. We're not replacing any astronauts. We're augmenting their capability. Imagine if the lunar rover on Apollo could keep up with the astronauts as they drove around. New robot. I don't know if you've gotten to see some of Boston Dynamics videos that they've done of their Spot quadruped robot, and it's fast. There's no question that these robots can keep up with a person walking in the field. And even if they can't keep up with an astronaut, there's still that independent ConOp where they're off doing geology on their own. Think about a hyper smart Mars rover that it is literally as smart as a person, because it's a person operating it in real time with real teleoperation, rather than uploading commands and putting that in a sequence to be radiated to the spacecraft. It's done basically in real time. So
Right. I hate to cut you off here, but I want to
augmenting it.
I hate to cut you off, but I want to get one more question in for Jose in our last 30 seconds. Has anyone done any analysis or prediction of the Artemis data streaming volumes compared to the communication channel constraints? So the Virtual Explorer tool might be a good way to model prioritization, but these kind of constraints might be a good way to identify value.
Yeah, that's a great comment. I can't speak to what studies might have been done. I'm sure there's someone in the audience who might know far more about that than I do. But I agree that, some concept like this, to stress the system, as it were, to figure out just how much bandwidth we have and how much we can fit through that pipe, I think that would be a valuable study.
Okay, so we have run out of time for our Q&A.